I am super pleased to open this tutorial on AP Physics C mechanics, and I'm just going to go ahead and briefly introduce you to content and everything. So this course is basically AP Physics C mechanics. It's going to be through online. Basically, we're going to have the Zoom sessions, and these are live sessions. Follow-up is going to be handouts and homework assignments. So it's really almost a virtual one-on-one type of a tutoring or preparation of AP Physics C mechanics. We do have Canvas page that I'm going to talk about in a moment. So the dates are from February 4th to April 28th, and it's going to be held on every Sunday from 1 to 3 p.m. Central Time. And if you're living on a different time zone, then it's going to be, for example, Pacific time is 11 a.m. Eastern time, where I am located, it is at 2 p.m. Make sure to check your time zone so that you don't really miss any classes. And please note that there'll be no class on March 10th. A little bit about me. My name is Islam Bidir. My students call me Dr. Bidir, and I did my bachelor's degree in physics, pure theoretical physics, master's degree again in theoretical physics, PhD in theoretical physics. I specialize in quantum chromodynamics. It's a field of physics that will explore subatomic particles, and all the things will go in the world of the subatomic beautiful particles. And I have also participated as a young student in my middle school and high school and beyond. I did participate in dozens of many physics contests. I actually started with biology Olympiads and then decided to switch my gears and switch over to physics because physics really appealed to me more than any other subject. So that's why I hide my very deep passion and zeal in physics. That's why I started really attending contests in physics. So currently, after doing my PhD, currently I'm really teaching computational physics, which really do combine the two fields. One, pure theoretical physics, college level, university level, and then at the same time, it is computational, which I do through Python. So in other words, I teach my students Python from very beginning, how to program in Python, and also I teach them physics, and in the end, down the road, we kind of merged it together, and that's basically my course called computational physics. So a little bit about me, that's actually posted on the website Momentum Learning, so you can check that too. So this is the Canvas page. Basically, one student will sign up, they're going to see this. For convenient, we did put link to join live sessions by just one click. And then also we have divided into weeks. So whenever students will log into Canvas, as soon as they click on week 1, week 2, and so on and so forth, they'll be able to access all the documents we're going to provide them, right, after sessions. So be it homework assignments or recordings of the live sessions or handouts I'm going to plan to post there. So basically, we're going to go through one-on-one, like virtual Zoom meeting, live sessions, but also sessions are going to be recorded so that students can actually catch up and watch later if they really miss any session, or to reinforce again the concept, they can definitely watch again. So in Canvas, we are, once they click on, for example, week 1, week 2, whatever, right? And going to link them to module in which they're going to see handout, homework, reading assignments, and so on and so forth, right? Students are always encouraged to follow closely things and materials posted in Canvas because Canvas is the tool, learning management tool in which we check the progress of the students, how they really move along, right? Otherwise, it's really hard to tell who is learning what. All right, now a little bit about AP Physics C exam. AP Physics C exam, there are two AP Physics C exams. So one's called Mechanics, which really include several chapters in classical mechanics. And I'm going to talk about them a little bit later, but basically, and there's a second one that's called AP Physics C, Electromagnetism, right? We'll call it simply AP Physics C E&M, right? Electromagnetism. And both of these, AP Physics C and AP Physics Mechanics and AP Physics C Electromagnetism, is considered one of the most difficult exam College Board has, right? their exam options. Really, if you consider with biology and chemistry and all other, although, for example, receiving, for example, 5 out of other things are also quite low. Um, I don't really have here C for some reason. C didn't really make it up here, but it's going to be very low as well. I'm not sure why it's not here. So this is AP Physics 1, AP Physics 2, but these are different than AP Physics C. That line should be there, in which earning 5 out of 5 out of 5 is very challenging, very difficult, and that's where this course really comes in, right? And that's what we ensure that students really learn well the content, the concept, and they are prepared extremely well so that they can just handle these AP Physics C mechanics, and they'll be off and go. Now, what is the advantage of taking AP Physics C? Many. First of all, they learn physics, right? They deepen their understanding of physics, right? By solving really challenging and difficult problems, they also, again, reinforce the concepts in their mind, and then they learn physics really in a wholesome, in a very strengthened and deep way. And number two, when they go to colleges and if they prefer to skip this entire physics, university physics, they can do so because they already have taken AP Physics C, right? So the first part, mechanics, they can be considered. Of course, it depends on the college, whatever the college you're applying. You need to check with their policies in terms of AP credit policies. So even if they choose to take University of Physics at their college, then this course is going to really lay out the foundation needed so that they can prosper. They're going to enjoy instead of really have hard time at the college, at MIT or otherwise. So for example, I have students who came from MIT and other places and really told me that how easy it was for them, to just navigate through this University of Physics because they already actually knew the fundamentals and basics. The format of this exam is very simple. They have 2 sections. Section 1, it's a multiple choice. They have 35 questions, multiple choice questions that is, and given is 45 minutes, which is really enough for students to get by and solve all these 35 questions. Most of them are conceptual. And it's really, even those that are not conceptual or numeric problems, they are easily done if students really know the physics concepts really well. In section 2, they have only 3 questions, and this is what we call free response questions. Again, 45 minutes is given, and section 1 and section 2 is divided into 50-50 overall grade, right? So they have to succeed in both 1 and 2. And so free response questions are available on their website, and which we're going to also focus on and go through and learn how to solve, how to approach these problems. But unfortunately, multiple choice problems, they don't really post them. And what I have done, I've made sure that I have gathered all the relevant, very close problems, right? Sometimes there are official problem set 1 or 2 maybe on their official website. And whatever I have just put them together, making sure that all these multiple choice problems are very close to, if not identical to, a College Board AP Physics C mechanics multiple choice question styles. So that's that. A lot of the times when prep courses are presented, students are really solving some not related problems, which I sometimes look at them and say that, well, how is that really helpful? And in this course, I am trying my best to ensure that students are getting relevant material, right? In during the Zoom sessions and also with their handout. So units are as follows. As you can see, there are only 7 units, not much. And then distribution of the units are as follows. So majority of them are coming from, for example, first 4 units or actually 5 units. But if students really ace in mechanics, that is kinematics in 1 dimension, 2-dimensional motion, and also Newtonian laws like forces and acceleration and all of those really dynamic problems, then they can actually do well. And by the way, all this rest of the chapters, chapter 4, 5, 6, and 7, they're all based on the first 3 units. They're very simple in that regard. So I'm going to ensure that students really spend enough time with ample questions needed for students to kind of have a very good grasp of the concepts. So kinematics, and so we're going to go unit by unit. Perhaps we're going to spend 2 sessions per unit, and that's what we'll have. Sometimes we're going to really squeeze them, and I believe we'll have enough time. All right, so textbooks. There are a number of really great textbooks. For example, Fundamental Physics, University of Physics by Young, and this is by Walker, right? Gerald Walker, and then by Professor Friedman and Young, and then there is a Giancolli, University of Physics. And there are also other like type of physics books that we can talk about. Which one do I prefer? I actually don't have a strong preference to one. For example, let's say this first book, Fundamental Physics. I love certain chapters and I don't like rest of the chapters. For example, Fundamental Physics will handle gravitational field and forces really nicely, while these two will just skim through some important concepts. But overall, I think all of them are really great. But if I were to really choose one and only, perhaps that will be this last one, Universal Physics by Giancolli. But in any case, I'm going to really give some details about this book. So this is 14th edition of Universal book, Universal Physics by Young and Friedman. It doesn't have to be 15th edition. 14th and 13th and 12th, whichever really cheaper side, that will be just sufficient because physics hasn't really changed for the past 2 decades. So no worries if it's a really older version, it's not going to hurt at all, right? It's the same concept physics textbooks will cover. Fundamental Physics, Volume 1 is all you need for AP Physics C. It's a very great book. I like this book very much. And it's about perhaps like $70 from Amazon, and Amazon link is also given. Some of these textbooks are available online as a PDF form, but I'm not going to really recommend any electronic version because I believe really is that physics should be learned with a hard copy, printed copy, by having students really annotate with pens, right? Annotate them and write those equations again and again, not just read it through kind of a Kindle device or from the screen of a computer where there's a lot of distraction, especially nowadays. So I would definitely recommend getting a hard copy of any of these books. So for example, Giancolli, uh, although it's very difficult to obtain the hard copy, right, of this edition, however, on their website, which I did actually include a link, they are providing the rental hard copy for $75 per year, I believe. So I think it could be affordable for students to just get the hard copy from their website. They're going to ship that. And once students really, if the students really love it, they can keep the book for cost, I believe. And there is one more book I would like to really present that I really want to, and this is for physics fans, really. If you are into and very deep passionate about physics and beyond AP Physics C, such as F equals to MA exam or US Physics Olympiad, there is this one golden physics book. Not an easy book to read and to understand. It's really thin, but goes through exploration, goes through derivation of physical quantities and formulas and things like that. So it really gives about a very broad, beautiful perspective of physics. They don't really print this book anymore, but you can find maybe through eBay for about under $10. I'm aware of prep books such as AP Physics C by Princeton Review, different type of books. All of them, I have all the copies of different books for which I am going to be utilizing in our course. So students really don't necessarily need any of these books. Should they look into them, will that benefit? Perhaps, yes. But I'm going to include the content and the beneficial parts of these, prep books into our sessions. So they'll be infused. Now, this really brings us about sample problems, momentum. Admins asked me to walk some students through some of the problems really close to AP Physics C problems, official problem sets. And for example, in this problem, as you can see, so it says, suppose x velocity of the car at any given time, t is given by this equation. So the idea is to derive an expression for the instantaneous acceleration as a function of time in x direction. So given this problem, right, given this function, how do you really find acceleration? Now, if student hasn't taken calculus, this is going to be a challenge because it does require a little bit calculus knowledge. But if your student haven't taken calculus, that's all right, because at the very beginning, I'm planning to walk them quickly through to enough calculus needed to solve problems in AP Physics C. For example, this problem, right, requires a little bit integration. So what do we do? We need to find acceleration. Now, how do we find acceleration? Well, by simply remember that acceleration is defined as the time derivative of velocity. So given this, if there are any students, you are welcome to chime in the chat box or unmute yourself and tell me how to do this, how to perform this problem. And if you just want to sit and listen, that's totally fine. So yes, all we gotta do, we need to just take the time derivative of this equation, that is 60 and 0.5 t squared. So in derivation, we know that the constant is going to give you simply 0, and this part is going to be, this 2 will come over here multiplied, and we're going to get 2 times 0.5 times t. And we are done, basically, right? So that's going to be our acceleration, right? So time derivative, and that's our acceleration. And we're done. As simple as that. What else? Now, if you were to look into, for example, this problem number 2, in which this one requires integration. The previous one required a time derivation. This one requires integration. Integration simply means finding the area of a function. So in this case, the function is going to be acceleration. Let's look into this problem. Sam is driving along a straight highway. At t equals to 0, when he is moving at 10 meters per second in the positive x direction, he passes a signpost at x equals to 50 meters. So his acceleration is given by this equation. Find his velocity and position as a function of time. So how do you find the velocity when acceleration is given? So in college physics, normally this question is not asked because it does require derivation. So in other words, if you remember, we know that acceleration was defined as what? Time derivative of velocity, which simply means that velocity equals to a times delta t. Now, what do we do next? So we need to find velocity using this infinitesimal delta v, using this infinitesimal time. So all we're going to do, we need to just take the derivative from where to where. We need to specify the boundaries. So in this case, it's going to be from initial velocity to any specific velocity. From here, it's going to be again from initial velocity, right? Initial velocity to any velocity t. We know that the initial velocity is going to be 0, and here we know that the initial velocity is going to be 10 meters. So given this, we see that here it's going to give us v minus v naught. That is the left side. And the right side of this integration is basically, let me do it here. It's going to be from 0 to t, and the entire equation is that 0.1 t delta t. So when we are taking integration, when we do integration, what we do is that we just, if you were to imagine t to the power of 0, then 2 to the power of 0, that's going to increase. So it's going to make it 0 plus 1, right? Over 0 plus 1. And then minus 0.1 t, it was 1. We're going to just increase by 1, and we're going to divide by the whole number, which is that 2. And we are done, right? Because it's a definite integral, we don't have any constants. And so we can safely write down as what? We can safely write down that this is 2t minus t squared over 20. And knowing that the initial velocity was 10, we can rewrite the whole thing as velocity, right, time-dependent velocity, that is, equals to 10 plus 2t minus t squared over 20. That's it. Very simple indeed. But now the question is, if I were to ask, like, when is it? When the velocity of this car maximum? At what time, in other words, the velocity becomes maximum? Now, students, again, not taking calculus, not taking, for example, they might be a little bit confused, but there's really no need because we know that any function is going to attain maximum when the slope, right, actually gives you 0. In other words, the tangent to the line is really 0. What it means mathematically is that we need to simply take the derivative of velocity and then equate to 0. In other words, this is what we need to do. Given velocity v, that is, what was it? 10 plus 2t minus t squared over 20. Right, bear with me. I know this is a little bit technical, but since they asked me to walk through some sample problems, I'm going to just go through this one. Now, because it's constant, it's going to give us 0. Now, this is going to give us simply 2. And this 2 will come here as a multiplier and giving us 2t over 20. And the whole thing has to be equal to 0. And that's what the meaning of maximum or minimum, right? So in this case, it's going to be maximum. And so from here, we see that the t equals to, let me see, so that I don't really make any mistake. So we'll have 2 here, and then we'll have, it's going to be 20 seconds, and we're done. So in other words, at 20 seconds, car reaches the maximum velocity. Let's quickly test this. When t equals to 20 seconds, right? I'm going to put it this way, 20 seconds. What happens to the equation? If we were to plug this 2 on times, now 20 seconds minus 20 squared, which is 20 times 20 divided by 20, right? And then some things cancel out, as we can see, and the whole number gives us 30 meters per second, and we're done. So that means maximum velocity is going to be 30 meters per second, right? So in other words, car reaches the maximum speed at t equals to 20 seconds, and the speed at that very moment is going to be 30 meters per second. So that was second problem. And one last problem, I'd like to challenge perhaps some students if you want to be challenged. And it's a very simple problem, actually, not very hard, from AP Physics C, I believe. And here we have 2 blocks. A block of F, right, of mass M1 is on top of a block of mass M2. The lower block is on a horizontal surface, and a rope can pull horizontally on the lower block. The coefficient of kinetic friction for all surfaces is given as mu, right? Greek letter mu. And what is the resulting acceleration of the lower block if a force F is applied to the rope? Assume that F is sufficiently large, right? Sufficiently large so that the top block slips on the lower block. So in other words, here we have the slipping, and then this block is being pulled by F. In all surfaces will have friction coefficient mu. So how do we solve this problem? Is there any students who want to unmute and tell me quickly? And I promise this is now going to be the last problem, right? No worries at all. If you want to really help me to solve this problem, that will be wonderful. If you want me to go through, that's fine as well. Okay. Now, again, students sometimes when they see this kind of problems, they say, well, I have no idea where to start, all this, but no need to, because when they really learn concept, they can immediately do free body, what we call free body diagram. In other words, they can choose any mass, for example, M2, and then they identify all forces acting on M2, right, on this mass 2. For example, in this particular case, it's the external force F, right, external force F. What else? It is going to be, it's going to be what? It's going to be its weight force, which is M2G. What else? there is this mass exerting its weight force on it as well. So I'm going to write here M1G as well. What else? Well, there is also normal force by the surface, right? So we're going to include that. And finally, friction. So there is one friction force by the surface over here. Let me do it in red. So this is the friction 1, right? I'm going to call it F1. But then there is also friction between these, right? So when this object is sliding on this block, it exerts a friction force in the opposite direction, right? So in this case, it's going to be just on it, right? Let me write it like that. Okay. So and the friction force is going to be applied on it as well. So the students really know what's happening here, right? And finally, let me write that down as well. That's it. Now physics ends here, ladies and gentlemen. That's it. This is the end of the physics. So this is basically what we call conceptual. And this is easily about, I would say, more than, right, or perhaps 90% of the solution, really. If you're able to come all the way until here, then you're good to go, because the rest is simply applying the Newton's second law, which is basically mathematics, right? So all we do is next is that F net equals to, in our case, because we're dealing with M2, is going to be M and that. Okay. So how do we do that? What is F net? F net is the net resulting force. So that's going to be external force minus friction 1, which is mu times, right, normal force. That is a combination of these two weight forces, M1 plus M2G. But also, we need to subtract F2. That's going to be mu times M1G equals to M2A. All in A, right? And then all you need to do now, you need to just simply divide by M2 to find the answer. In other words, right, acceleration is going to be F minus. See here, we have two M1s, right? Two M1s. So that means it's going to be mu 2 M1 plus M2G, and the whole thing is going to be divided by M2, and we're done. So that was, again, our last problem I wanted to quickly discuss and show how things will work. But of course, during our session, in this live Zoom sessions, I ask students to read these problems, and then I invite any volunteers, any students really to help solve the problem. As they engage in it, they have a better understanding how physics problems are solved and how conceptually you approach these problems. And that actually leads us to the end of the session, for which I'm going to collect your questions if you have any. I don't promise to answer all your questions, but I'm going to be answering any questions that I know the answer for. So let me see. Okay, it's your questions. Michelle, oh, okay, and then we have Jensen, we have Celia. Anyone, if you have any questions, please let me know so I can walk you through or try to answer my questions. If you have any further questions, for example, you have any questions, and then that comes to your mind later, you can definitely go ahead and reach out to Momentum Learning through their phone and things like that. If you know my personal email, you can also do so as well. And that's basically it, ladies and gentlemen. Thank you very much for joining. It was a pleasure, and I hope to see you during our live sessions. All right, let me see if you have any questions. Thank you. Yes. Yes, Michelle, the amount of the calculus is actually very basic. In other words, the amount of the calculus the students really need for AP Physics C is next to really nothing. I mean, For example, the problems that I really showed here, it's just this much of calculus. If you know this much of calculus, which is basic derivation, right? And this much of integration, all is you need. That's it. So that means you have enough calculus information needed for AP Physics C. And one more thing, of course, needed here is to realize when you need to apply these, right? That's it. So if you know when you need to apply derivatives, right, to obtain another equation, and also when you need to apply, let's say, integration, right, integral to obtain another function, that's basically all needed in AP Physics C. It's not super high level mathematics at all. So that's why, for example, in my course that I teach at the local institution, I always really, had an idea of, just remove college physics altogether and stick to university physics because there's really no difference between the two subjects. College physics, in which approach is algebra based, while university level physics approach is calculus based. And where do you actually see the difference much? One or two problems, really, not much. So yes, what I would finally summarize is that if you can get one of these textbooks, that will be great. For example, it could be fundamental physics, it could be university physics, or it could be Giancoli. Currently, my favorite one is actually this book, Giancoli Physics. Amazing, beautiful, concise, not so much concise. I mean, because it's very thick. And the reason is because it includes a lot more chapters than needed for university physics. But otherwise, it's a beautiful written book. Teaches physics the right way, I think. All right, any further questions? All right, I don't see any. Yep, I hope, Michelle, this answers your question. Okay, all right, thank you. And once again, thank you for joining and hope to see you again. Goodbye, everyone.